start our second lesson, or I guess third lesson, where we're going to continue to work with linear patterns and working with tables. So same objective today as yesterday. We're just going to kind of build on these concepts. So our objective for today is to be able to identify initial value, which we're actually not going to do a whole lot of. Instead, we're going to focus more here on the rate of change from a table of values. So yeah, let's jump right into it. So when you're watching a video, I'm going to often ask you to pause the video and work through a problem. Really important that we actually take the time to do that and still practice these problems without me just showing you how to do it. So for this warm up, here in a second, I'm going to ask you to pause and then in your groups complete the warm up just like you would as if I was here. Come up with the ROC and then the unit ROC. So go ahead and pause right now. After you unpause the video, I'll have everything worked out and we'll make sure we all have the right values here. All right. So on the right side, we have our changes in y's, where I'm noticing that we're subtracting 4 every time. On the left, I have my changes in x's, where we're adding 1 every time. So the rate of change, if I take any change in y and divide it by a change in x, we're going to get to be -4 divided by 1, which since we already have that per 1 for the x, that is the same thing as our unit rate of change. So both rate of change, unit rate of change from this table are -4/1, or just simply -4. So now let's look at some other tables where we're going to kind of see how this might be different today. So for the second table, let's find all these changes in y's, a little bit smaller table here. So -8, -8, -8, and -8 one more time. For the x's, we're adding 2, adding 2, adding 2, and adding 2. So once again, I'm noticing that it's the same change in y all the way through, the same change in x all the way through. We actually saw this in our lesson yesterday. So the rate of change here, change in y divided by change in x, is -8 divided by 2. Okay, so that means for every 2 units of x, we're moving down 8 units in y. So now, how does that get to our unit rate of change? Remember the unit rate of change, we need to figure out how many y's per 1x. And the way that we do that is just simply divide what the ROC is. So doing -8 divided by 2. So -8 divided by 2 is -4. So that unit rate of change is that we are moving down 4 units per every 1x. All right, so again, this is what we had seen yesterday, so nothing new there, just reminding about how we get to this unit ROC. But if we look at this next table here, and specifically at the x's, I'm adding 2, and then adding 3, and then adding 3, and then adding 1. So the change in x, well, not to use the word change again, but it's changing every time, right? We're going 2, 3, 3, 1. So now, if I look at these corresponding changes in y's, we subtract 8, then 20 to 8, that's -12. 8 to -4, also -12. And then -4 to -8 is -4. Same idea, right? We're getting different changes in y's. So what are we going to report back for what the rate of change is? It doesn't matter. Okay, as long as we take a corresponding change in y and its corresponding change in x, we can say that it's -8 divided by 2, -12 divided by 3, or heck, even -4 divided by 1. All of these represent values that are the rate of change here. So let's just use the top value there, -8 divided by 2. And then if we scale that down and find the unit rate of change, well, heck, we just did that exact same thing. It's -4. Okay, so -4/1. Well, look at this last part in the table here. When I go from this number to that number, I'm adding 1. And from -4 to -8, I'm minusing 4. Okay, so we even see that unit ROC in the table when it's just per 1x. And that's, again, what we're going to keep coming back to about that unit rate of change. How many y's per 1x. So this is what we're going to work with today, where the x's are kind of jumping over the place and thus the y's are going to jump over the place. And so we just need to, again, work on the same concepts of identifying change in y and taking its corresponding change in x. All right, let's go ahead and flip this page over. If at any point this gets moving too fast, of course, pause the video and get caught up, and even try working on some of the problems. So I'm even going to structure this video the same way as to how we did class, where I'm going to do the first problem, then I'm going to ask you to pause and have you work through 2, 3, and 4, just like if we were in class and I said, hey, go ahead and do 2, 3, and 4, and then we'll check the answers after. So let's try number 1. Well, let's go ahead and find, in this case, for this lesson, let's find all the changes in y's and all the changes in x's. So 20 to 60, adding 40. 60 to 84, adding 24. 84 to 112, this is a bigger number. When we have numbers that maybe it's kind of tricky to find, if you want to find the change, use the calculator and take the bottom number minus the top number. So for me, that's 112 minus 84, 28. So adding 28, and then 112 to 160, I'm going to do that again. Some of these numbers, when they're bigger, it's hard even for me to do, so plus 48. Okay, so now let's go ahead and do the same thing with the x's. 5 to 10, adding 5. 10 to 13, adding 3. 13 to 17, adding 4. And 17 to 23, adding 6. So now if we find the rate of change, okay, it's either 40 divided by 5, 24 divided by 3, or 28 divided by 4, or heck, 48 divided by 6. Let's see if we take all of these changes in y's and divide by change them in x, they give us the same unit ROC. So 40 divided by 5 is 8. So that's telling me right now that we think the unit rate of change is 8 y's per 1x. Let's see if that holds true for the others. 24 divided by 3 is 8. 28 divided by 4. Ooh, something's wrong there. Maybe that's supposed to be 38. Let's try that again. 112 minus 84. 28. 13 to 17. Hey, that's a typo. Because 48 divided by 6 is still 8. So yeah, this is a typo here. Ignore this one. That was supposed to work out a little bit different. So just pretend that we didn't see that one. Okay. Anyway, all of these rates of change, when we take change in y divided by change in x, is always 8. So the unit rate of change in y divided by change in x, is 8 divided by 1. And again, sorry for that typo there. Was it a typo? Yeah, I don't know what happened because it works for all the rest. Anyways, that's it. That's all we're doing today. So just like I mentioned, I want you to pause the video. I want you to find every change in y and every change in x. Just quickly make sure that they're all the same, and then we'll report what the unit rate of change is after we're done with that. So hit pause. After you're done working through 2, 3, and 4, then you can unpause the video and check your work with what I have. All right. So as you can see, a lot of these changes in y's are going to differ from one output to the next. Same thing with a change in x's. Now, for any change in y divided by its corresponding change in x, and I wrote them all out right here. So basically, everything I have here, these are all just the ROCs, the rates of change. So for every 3 y's, we're moving 4 x's. 1.5 y's, 2 x's. 6 y's, 8 x's. 9 y's, 12 x's, which breaks down to our unit rate of change being 0.75 y's for 1 x. I'm getting that 0.75 by just doing this division. Okay, all of these equal 0.75. 3 divided by 4, 1.5 divided by 2, 6 divided by 8, 9 divided by 12. They all get to that same 0.75 there. Okay, and that is our unit ROC. Okay, number 3, really no difference here. Same idea. Find all the changes in y's, all the changes in x's. All of these rates of changes, they all eventually equal and reduce down to 4 divided by 1. So the unit rate of change, when we change 1x, that is a change of 4 y's. Now, number 4, we have that same kind of issue where one of them does not work. Again, that is not intended. That is more of a mistake on the planning part. So ignore this 20 divided by 5 that you get here, because that's going to give you a different rate ROC than what the rest of the table is. Okay, so I'm using this 10 divided by 2, 5 divided by 1, 30 divided by 6, and 20 divided by 4, all of which end up being 5 over 1. So the unit rate of change here is 5 over 1. Okay, you have a second page where now, and if you don't have this yet, go track down the subs so that we do get to the second page here. We're going to do the same thing, but then we're going to use this unit ROC to help us fill in other parts of the table. So we actually want to start this the same way as what we did prior. We're going to find all these changes in y's and changes in x's, and we're going to use that to then fill in the rest of the table. So 39 and 32, I have to minus 7. 32 to 25, minus 7. 25 to 18, minus 7. 7, 7, 7. Okay. Now for the changes in x's. I'm going to do this for every change in x that we have here, including the ones that don't have y values yet. Negative 8 to negative 6, I got to add 2. Negative 6 to negative 4, add 2. Negative 4 to negative 2, add 2. And it looks like we're adding 2 every time. Okay, so our ROC here, or the change in y divided by change in x, is negative 7 over 2. So this means for every 2 units of x, we subtract 7y. Well, since the table, we're just adding 2 every time, that already tells me what I need to do to these y's. Just keep subtracting 7. The unit ROC we really don't need here. Okay, so let's finish this table and then we'll talk about the unit ROC. So 18 minus 7, maybe I just get a calculator and take all the thinking out of it, is 11. 11 minus 7, 4. 4 minus 7, once we get into the negatives, that's when some of our brains start to hurt, is negative 3. Okay, so then the unit ROC, once again, we'll take any rate of change we find and divide it. So negative 7 divided by 2, where it's negative 3.5, and we'll put that over 1. So negative 3.5 over 1 is that unit ROC. Okay, so as long as the changes in x's stay constant, we can keep doing our changes in y's that we did for all the same change in x's. Now let's see if that holds true for what we need to do on, not number 6, but number 7. Okay, so you're going to do 6 and 8 in your groups. All right, number 7, same idea. Let's go ahead and find changes in y's, changes in x's. 60 to 100, I add 40. 100 to 116, I add 16. Okay, those are the only 2 that we have here. Okay, then there's a big gap here between the 116 and 180. I'm not going to do anything with that. Instead, I'm going to find all of these changes in x's. So 5 to 6, add 1. 6 to 10, add 4. 10 to 15, add 5. Add 2, add 5. And then add 3. Okay, so using these values we have here, we know that the rate of change, or at least for one of them, if I take this change in y, which is 40, and its corresponding change in x being 5, we get 40 divided by 5, which is 8. Okay, so our unit rate of change tells us that for every 8 units of y, we move 1 unit of x. Now this is going to be key to helping us find these other values, because we know how much we're adding on these x's, and so we can use this unit rate of change to multiply how much y's we need to add here. So what do I mean by that? Well, from 17 to 22, we have 5 x's. So that means if I have every 8 y's per 1 x, and I want to figure out, okay, well, what do I do with 5? Well, we're going to multiply this unit ROC by 5 by 5, or by how many units we plan to expand it to. 8 times 5 is 40. 5 times 1 is 5. Well, didn't we just do that? Right? For every 5 units of x, I go up by 40. So here we're going up by 5 units of x. So I'm going to go up by 40 units of y. So let's see what that equals. 116 plus 40 is 156. So let's see if this worked out to where the scaling is the same. So this is saying for every 3 units of x, that would mean we need to do 8 times 3 units of y. 8 times 3 is 24. Well, from 156 to 180, we are adding 24. So that worked out nicely. So now we got to go backwards. Okay, and again, to fill in these other values, we're going to use the same unit ROC plan, or same concept here, where in this next value, I know that we have 4 units of x, so how does that correspond with our unit ROC? So if I take the 8 divided by 1, and I multiply it by 4, multiply it by 4. That is 32 units for every, or 32 y's for every 4 x's. So I know whatever number we put here, I need to add 32 to it to get to 60. So I'm now thinking, what number plus 32 is 60? Well, I can also just reverse the operation and do 60 minus 32 to find that number. And that's 28. Now I'm going to check this. 28 plus 32, is that 60? Oh, it sure is. Thus, we're right on the right track here. Okay, so now for the last one. 5 to 6, that's 1x. That is exactly our unit rate of change. So I know that whatever number we put here, I need to add 8 to it. So add 8. So what number plus 8 is 28? Or 28 minus 8 is what this number needs to equal, and that's 20. So 20 plus 8 is 28. And now our whole table is filled out. So to kind of summarize that, we need this unit ROC, and then we can take any change in X and we just multiply that change in Y by that amount to figure out how much we need to add here. Definitely got a little bit harder on these last 4. So I'm going to again ask you to hit pause and work through problems 6 and 8. After you unpause, we'll complete these 2 problems, and then you can start homework shortly after. All right. Well, let's look at number 6, where, again, we're kind of having to backtrack to fill in the rest of this table. But using the values that are filled in, I found all the change in y's to be plus 8, all the changes in x's to be plus 4. So the unit rate of change is 8 divided by 4, which is 2 divided by 1. So for every 1 unit of x, we're moving 2 units in y. Or, since all of these changes in x's are 4, well, multiplying our unit rate of change by 4 gets to this 8 units of y for 4 units of x. So I know that as I work my way down here, I need to keep adding 8 to get to the next number. Now, since these numbers come before the ones we have filled in, I need to do the opposite. So when I'm thinking about how I got negative 32, I'm thinking about negative 24, or what number plus 8 gets me to negative 24, which is essentially me thinking about negative 24 minus 8. So I'm basically undoing the operation I've wrote down as my change in y. So negative 24 minus 8, negative 32. Negative 32 minus 8, negative 40. Negative 40 minus 8, negative 48. And so now when we add 8 every time, we get the consecutive or the next output. Okay, well, let's look at this last one, as this is definitely the trickiest one we have here. And we only have one change in y and a corresponding change in x that we can use to find the unit rate of change. So here I have to minus 8 and add 2 to x, so negative 8 divided by 2 is negative 4 divided by 1. So this unit rate of change is our key to everything. So before we start to think about these numbers, let's use this unit rate of change and figure out what we need to add or subtract for all these amounts here. So for the 3, we know for every 1x we're moving negative 4y. So for the 3, we're just going to multiply that by 3. So negative 4 times 3 gets this rate of change to be negative 12 y's for 3 x's. So I know I need to subtract 12 there. Okay, how about for 2? Well, for that rate of change of, negative 4 over 1, and I multiply it by 2, I get to negative 8 divided by 2. So that means for 2 x's, I'm going down 8, which is what we used to find the rate of change in the first place. Okay, so the next one, we got 5. So let's take that negative 4 divided by 1, multiply it by 5. So I get negative 20 y's for 5 x's. So minus 20 here. A 1, we already know the 1. That's that unit rate of change. That's down 4. And then 4 to 10 is 6. I'm going to just multiply that one more time. Times 6 times 6. I get negative 24. 6, so minus 24 here. And so now I have all the changes in y's that can help me brainstorm what these numbers need to get. So this works out nice. We don't really need to think about the opposites and going up from the opposite way of how we found these changes in y's. So I can just work my way down. 22 minus 12 is 10. 10 minus 8 is 2. That works out nicely. 2 minus 8 is negative 6. Again, that works out nicely. Negative 6 minus 20 is negative 26. Negative 26 minus 4 is negative 30. And negative 30 minus 24, negative 54. All right, so this definitely stepped it up a notch. Going to have to think a little bit more than what you did in the first lesson. But again, thanks for sticking around to the end of this video. You can now go ahead and show the sub your completed notes and begin your homework. Have a great rest of your day.